Hello, everyone, and thank you again for joining us today for our second in a series of webinars on behavioral analysis and predictive analytics. And today we're going to focus on ConicIT, the solution. Just as before, we'll be taking questions at the end of the webinar, so please feel free to submit your questions via the chat box on WebEx. If you have questions after today's webinar, please email us at performancequestions@sdsusa.com. Our agenda for today's meeting begins with introductions of our company and our partner, ConicIT. We'll discuss the issues surrounding IT performance management and behavioral analysis, the ConicIT solution, including its architecture, installation, profiles, and rules, and we'll discuss some key differentiators about ConicIT with regards to other things that might be in the marketplace today. We'll also discuss some case studies and customer benefits. And again, we will end with a Q&A session. I'd like to first introduce our company and our partner. SDS, or Software Diversified Services, is celebrating our 30-year anniversary this year. We're headquartered in Minneapolis, and we have over 1,000 customers and distributors globally with over 20 mainframe software solutions, and we pride ourselves on world-class customer support. Many of you are familiar with our vital signs solutions for the network, along with our security solutions for encryption and protecting your network. And of course, SDS is the channel partner and distributor for the ConicIT solution for behavioral analytics and predictive performance. Joining us today from our partner, ConicIT, is Jacob Ukelson. He's located in Israel. Jacob is their senior advisor. He has a proven track record in discovering and developing innovative solutions and has fostered innovation in many different environments, including both research and development in the business setting. He's a senior advisor and director at ConicIT, having previously served as the CTO and business development executive at IBM's Global Technology Unit, and served as Department of General Manager at the IBM Thomas J. Watson Research Lab in New York. At that point, he was managing a group of 130 cross-disciplinary researchers. And I'm Deb Hodson. I'm located in Research Triangle Park here in the Raleigh area with 30 years in IT, having worked at IBM, Candle Corporation, the Omegamon company, and HP, all in sales management and consulting roles. I'm now going to hand it over to Jacob so we can jump into the heart of the problem of IT performance management. Jacob?
Oh, sure. Thanks, Deb. Hi, everybody. So I'm going to shortly go over some generic stuff about ConicIT that we spoke about last time, and then hopefully very quickly get into very specifically how the application actually works. So what do we see as one of the main issues in IT performance management? One key issue is the fact that there's lots of great tools out there for monitoring applications, but they give too many alerts. People tend to ignore them because you get too many alerts, or they set the threshold so high that they actually miss a lot of problems. And the reason this happens is that the systems really have no explicit knowledge of what is normal for your application and for your system. So therefore, people set standard thresholds, which essentially seem to be wrong more often than they're right. These happen whenever an issue does happen. When it's caught, it tends to be too late, because once the threshold is crossed and the alert is issued, what you're really seeing there are symptoms. And what I mean by symptoms, for example, is that if your application is running too slow or your system is running too slow, that is really a symptom. It's caused by something, some root cause that happened much earlier, and by the time you see the fact that your system is working too slow or a specific application is working too slow, everything is masked and you're just seeing the symptoms, and it makes it much, much harder to get to the root cause. And one big issue for IT is the users are the first to know, especially even in today's mainframe environment. Many of the applications used affect end users. And when end users are affected, they know about this immediately. They know they're not getting a response. But the IT operation doesn't necessarily know about these issues, and they tend to get calls either directly from customer service or from management saying that there's some problem with the system. And the reason this happens in mainframe environments is that these are very complex environments working and carrying a lot of different workloads. And in the transaction-oriented environment, the fact that you have shared resources is what's causing a lot of the problems. So even if your application tested really well, once you put it into production, it's actually sharing resources with other applications running production at the same time. This is true of any virtualized environments, but it's certainly true of the mainframe environment. And then these resources being shared cause complex interactions that even, again, if the application worked very well in testing, there's still problems in production. And what IT really needs is something that says, in production, here's where you should be looking. If there is an issue, they need to know about it. And once the issue they've been notified of the issue, they need a point saying, look over here. And the only way to actually get that is essentially to build a brain that gathers the information from the existing monitors, analyzes it, and creates the alerts and the deep dive analysis so that you can actually know where to look. And the way to do this is through something called behavioral analysis and predictive analytics. And what does behavioral analysis actually do? It sort of says, the system is going to learn about what's normal, what usually works, how your system is usually working. And then when something bad happens and your system doesn't work as it does as normal, it's easy to figure out that this is an anomaly and point you at the fact that this is an anomaly and you should be paying attention to it. So what it does is it builds up behavioral profiles over time, and these historical behavioral profiles create a behavioral baseline. They learn about your machine-specific applications on your machine and how they should be working over time. And the goal is to find anomalous behavior for those applications that can be an early indication of a performance problem. And this is, in some sense, very similar to the way an operator works. An operator isn't monitoring every single transaction and trying to understand exactly what's going on in every single possible subsystem being spawned off or being used by a specific application. What they do is they look at applications and they understand that things are out of whack, things are abnormal. And once they do that, they try to figure out what's going on. And in this way, they can figure out very quickly by using patterns what deviates from the norm, and then figure out what's going on and what's broken. So one of the issues is that when you don't do it that way and you're just using regular alerts, then an anomaly happens. So something occurs that makes your system work abnormally. Now the problem is that the problems are found way over here. So by the time your users are affected and IT knows about it, what they're really seeing is all of the symptoms that are going on. They don't actually get to see the root cause. What you want to do is you want to catch things as close as possible to the actual anomaly. And if you do that, then you're very close to the root cause. It becomes much easier to diagnose the problem. Another way to say it is essentially if you think about a crime scene and you think about the television show CSI, well, one of the things that make it so interesting and makes their job so hard is that they're actually looking at everything way after the fact. So they need to analyze what's going on and understand from that what the root cause is. So they analyze blood splatter, they analyze what's going on in a room. Just the same way your system folks need to analyze their logs and analyze past performance to try to understand what actually caused the problem. But it's much easier if you actually can see what's going on. So if you can be an eyewitness and you can capture the information about what's going on in the system when the actual anomaly or when the problem happens, it becomes much easier to understand that, hey, I don't really need to discuss much what's going on here. This guy stuck his hand in through the window, and this is what caused the problem. But what happens if you're late? And now looking at a real system, what you'll get is essentially a bunch of errors. And these errors start streaming out because once the system comes into an anomalous state and there is a problem, things start piling up. And then it becomes really hard to understand and separate the wheat from the chaff. So you'll be seeing lots and lots of different errors, but you don't really know what you're looking at and what you need to pay attention to. So what happens if you're late? Well, maybe you need some more capacity. That's certainly one issue, and people tend to throw more capacity at the issue if that's what they see happening. Maybe there's a problem with the database. Do you need to add extra capacity to your database? Is there some issue going on with your database? Because if the transactions aren't working, maybe there's some issue with your database. But if you can actually turn back time and look and see what happened, then you may be able to understand much easier what went on. And here, if I turn back time, what I get to see is essentially when these issues started to happen, there was this one thing that sort of kicked everything off. The CPU of the started task, T0DD T200, is causing a problem. It's over what I expected. And if I could capture that and understand it, I could start understanding the root cause much more quickly and get to a much easier analysis of the problem. So being able to see the fact that there was a spike for this specific CPU usage for this transaction, it makes it a lot easier for me to understand that I really don't need to worry about capacity. I really don't need to worry about my database. What I need to worry about is this specific transaction, and I need to fix that problem. So how does this actually work in ConicIT? Well, the way it works is essentially it uses a model, a mathematical model, that gathers information from your systems and the specific transactions as they're running, builds up this behavior model. And if you're looking at the screen right here, this is an actual screen from ConicIT. This green highway is essentially what's normal. And I now know if this is the past, I can see that here, for example, I went over what's normal, but if I can also this allows me to look into the future. It allows me to make a prediction about the way things should be. And then I can understand when there's an anomaly, like what's going on here, and I need to decide whether or not this is an important enough anomaly for me to pay attention to. And so, as I said, I found the anomaly, and I can do this mathematically. We've built models over 3 years of our existence, so this is what we spend our effort on, building appropriate models to statistically allow us to gather information from a specific mainframe system and build up a very good model of the way the application should be performing. And then it goes through a rule-based system saying, okay, I know this is an anomaly. Do I really need to alert on it or not? So once I've got all that information, I can decide whether or not they should alert. Now, of course, you also want the customer-specific configuration because even though there may be some real issue there, it may be a subsystem or an application that the user doesn't really care about. And, of course, you need to be able to tell the system to ignore those kinds of things, too. So the ConicIT solution uses sophisticated mathematics and domain knowledge about transactions on the mainframe and performance of mainframes in order to do its analysis. And what it builds is essentially a behavioral baseline, a way for our system to understand how your application should be working. It does this by building up this model over time. So it spends time watching your monitors and gathering information from your monitors and building up this baseline. It creates dynamic thresholds. So as I said earlier, static thresholds are problematic because if a static threshold is, for example, 70% utilization of the CPU, well, 70% utilization of the CPU may be good or it may be bad. It depends on the context. 10% utilization of the CPU may be good or may be bad depending on the context. And people don't tend to look at low utilization rates. But for example, low utilization rate, especially if the expectation is that it should be higher, could mean that you're having some problems upstream that are not letting things get into your system. Transactions are not flowing correctly. Then based on that, we use anomaly detection. You need to be able to point out things based on the model that are unusual. And you can use these anomalies to discover and predict when your system is working incorrectly and predict problems. And while you're doing that, since you know that an anomaly happened, you can gather more information about the anomalous behavior. And that information, when someone comes to investigate the problem, provides them with the eyewitness data they can use to understand the issue. So looking at a survey that just came out from DMC a couple weeks ago about what's going on with the mainframe. And so they looked at one important issue about unplanned outages, which is a big issue for mainframe shops. And if you look at it, they look at effectively four things: hardware failing, the system software failing, an in-house app failing, or a change process failing. And all of these, of course, are ways that cause unplanned outages. Now, if you look at the first set is what IBM Z-Aware is about. It's all about finding and using predictive analytics to find hardware failures and system software failures, which is great. That only covers about half the kinds of failures that you would see in a system. What ConicIT looks at, it looks at the other kinds. It looks at the in-house application failures, and it looks at failed chain processes. by building up these behavioral baselines, it allows it can understand when your applications are behaving abnormally, and they can be behaving abnormally for a number of reasons. One of them may be a failed change process. So now getting more into the details about ConicIT itself, install and configuring ConicIT. Well, the architecture is very simple. We sit on a Linux box that resides outside of the mainframe. This can be a Z-Linux box, which is fine, but we don't reside on the mainframe itself. And we do this for a couple of reasons. One of the main reasons is that we don't want to affect the mainframe at all, because we, of course, tend to work harder when the mainframe is in trouble. And you don't want to put more load on the mainframe when your mainframe is in trouble. So we actually reside outside of your mainframe. We don't reside in any critical path. And we essentially leverage the existing monitors. So whether you have a Megamon, Tmon, SysView, MainView, whatever monitors you have for whatever systems, we can gather information from all of those monitors. So it's not that we're limited to just getting KICS information. If you have Tmon from Tmon, we can get KICS information from Tmon. We can get your database DB information, DB2 information from Omegamon, if that's how you happen to do it. And we can gather up all of this information from the different subsystems, and we can do it across LPARs. So by looking to the system as if we're another user of the monitor, we leverage your existing monitors, and we don't require any sophisticated integration. We sit outside your system. We connect into your existing monitor using essentially screen scraping technology, and we look to your monitor as if we're just another user. So diving more into it, what I need to do is essentially decide on what systems I want to be able to monitor, and essentially what transactions I want to be able to monitor within that system. And I need to be able to tell ConicIT how to gather the data. And so this is actually very simple in ConicIT. What I do is I set up essentially the variables I want to be able to monitor. And I do this by connecting, by clicking and deciding on what variables I care about. And then going to the 3270 monitor, here we go, going to the 3270 monitor and just marking up the specific things I want to be able to see, how I gather information. It's a really quick way of doing this. It doesn't take more than a few minutes to set up the gathering of the information into our system. You can use this to gather specific variables. You can use this to gather multiple kinds of variables and combine them together in different ways. But essentially, just by pointing us and giving us a logon into your existing monitor, and using our tool to actually decide what you're going to collect, you can very quickly collect information of all different types from your existing monitors. Then what you can do is gather this information. Here we're gathering another kind of variable, a common storage activity. And again, we're just telling it how to leverage the existing monitor to scrape it and gather the information that we need from that. And essentially then our system runs and starts gathering this information. It doesn't put a heavy load on your system. It does this only once every so often. The initial state is doing this about once a minute. If it senses a problem, it can increase its rate of gathering, but not so much that it will affect your system. And you can, of course, tune this according to your needs. And it just shows you, this is just an example showing you how it's gathering information, what of the different variables are going into, what are the different values from the monitor are going into what variables that the system is then going to use to gather this information. So very quickly, you can set it up. It doesn't require more than a few hours to get our server up and running, connect it into your mainframe, and start gathering the information that you want. And then our system starts learning about your application, and it uses that to build up the behavioral profile of your system. So what is a behavioral profile? Well, behavioral profile is essentially gathering information about a set of points from your system and then fitting them to the model. And this is, for an example, is a time-related data profile where we're gathering information from your system. And what we gather is essentially these points. We're looking at different variables and gathering points about this variable. This happens to be CPU. And we see it has a very regular pattern. And what happens is our system then says, this looks like it's a time-related profile. And I'm going to be able to leverage ConicIT's knowledge of time-related profiles to fit your data into the appropriate profile and to modify the model so that it's appropriate for your data. And this is a very regular kind of data that's going back and forth going up and down based on a regular pattern of day of week. Now, of course, it may not just be day of week. It could be minute of hour, hour of day, day of week, week of month, month of year, special days. So it's not just simply trying to fit a model to the day of week profile, but it's really doing a lot of work of analyzing your existing data, your existing transactions, to gather that data and build up a model that is based on our existing model, so it tailors the existing models to your specific usage. Then, once it's done that, you have a behavior profile, and it can start looking for anomalies. And looking for an anomaly is important because you need to understand that systems are behaving abnormally, but not every anomaly is something that you want to learn about. And then there's a set of rules that work after an anomaly is suspected, and it starts checking more things. And it can start gathering more information about what's your system about and creating rules. Okay. Besides rules, there's also alerts. So we've created a behavioral profile, and we've now applied the rules. So once that happens, what is generated are sets of alerts. And these alerts are there to tell you that there's some issue of your system. And these are essentially, you can think of these as dynamic threshold-based alerts. So it's learned your specific system, how your application works, and it also applied these rules after the fact. And based on all of that, it starts giving you alert. Now, here's an example of our alert system. And this, of course, can be tied into your regular alerting mechanism, your dashboards, and so on. But we also provide our own alerting window. And here specifically, there's this specific transaction, the RSS7, and there's a problem with the QRTCP. And so it's gathered this information, and it knew this because it built up a behavior profile of these different variables, and it's decided that this thing is anomalous. So what can I do? I see an alert. I know ConicIT doesn't tend to give me alerts about things that I don't need to pay attention to, and I want to find out more about it. So the way you do this is you double-click on the alert to start gathering more information to try to understand more about what this alert is about, why this response time is longer than usual, and why my QRTCB is way above the current threshold, or the expected threshold. And so what it takes me down into is a more detailed data about what was going on. And so this is the information gathered again from your existing monitors, and is essentially saying, well, if I look at this in more detail, there's the first anomaly that the transaction is running slower than normal. We saw that, right? And it's running on CIC PIS1. The QRTCB for KICS PIS1 is higher than normal. So again, this is an anomaly, and these two things are related. And finally, 57% of the time, KICS PIS1 is delayed by a specific job, and this is the job PSY S76. So as you can see, as it gathers this information about essentially what was going on in the machine while this anomaly happened, it's giving me essentially the data that I need to start understanding very, very quickly what the issue is. So things are a bit clearer now. I've gathered the information. I know that there's a problem, and it sort of pointed me at the bits of information that actually were anomalous. So I can then request to see a graph of what is the expected behavior, and then what is the anomalous behavior, what's going on now. And so looking at this graph, I see our green highlight, which is essentially this is how I expect this variable to be behaving at exactly this time. And I can see that the actual behavior is very different. It's actually acting differently as a result of PSYS 76. And I can see another graph around response time. And the graph, another graph around response time. And this graph around response time I see behaving abnormally too. So it gave me the alerts. It showed me the data. I can ask for more generalization to understand what's really going on. And then I can reach my own conclusion. And my conclusion is that there's this job, PSYS 76, is the reason that this KICS is exceeding the service level. And now I know what I need to do is to do something about this job. And that, of course, is the analysis itself. And the decision is, of course, a human decision. And then you decide what you need to do about it. Should you cancel it, lower its dispatching priority? This is, again, something that a person needs to come to, but it becomes much, much easier to understand what to be doing because you now have both all the information that you need for an analysis and a pointer to what the issues are. And again, just looking at an existing screen capture from ConicIT, here is essentially what I said, the green highway. This is essentially for this specific variable. This is showing me what I would expect to have happen. As it's gathering data, it shows me the real data of what's going on. I can see everything in here is acting as normal. Next step, I can see that it's going over certain thresholds, and this would cause ConicIT to flag internally an anomaly and start analyzing this, basing the rules and deciding whether or not to give an alert. Here, for example, is a different anomaly. And in this specific case, what happened here was that this anomaly was large enough and lengthy enough and all the other rules that needed to be applied, that there was an alert issued. But this one over here, because it happened as a peak and things went back so quickly, it actually did not generate an alert. So it was a very dynamic threshold based on the behavioral profile and the rules applied after the fact to this specific data. So what are our differentiators? We work in mission-critical enterprise production environments. So we do this in we've done this in healthcare, we've done this in banking. And we know that we work and we can find problems in production environments. Our models are built specifically for behavioral analysis in Mainframe for performance. Again, one of the questions that sometimes we get asked is, can I use just standard BI tools? And the answer is, of course you can. But you're going to have to build up these models and have them be done correctly, the same models that we spent over 3 years and tens of man-years to start developing for ourselves. So if you knew the math and you knew the statistics and you could actually build a system, then you could start building a system like ours. But then, of course, you need to gather the data and all the other stuff around it. Our dynamic thresholds are continuously learning. We learn from the existing from your existing transactions, and we base our threshold on your system. And this essentially solves the alert dilemma of existing monitors, and essentially getting too many alerts, and then setting the thresholds that you actually get too few alerts. So by having this dynamic learning behavior and dynamic thresholds, we actually solve that problem. And of course, it's very simple to install. As I said earlier, it's essentially an external Linux box that connects into your monitors as if it's just another user. You can do it completely externally through a real box, like running Red Hat or SUSE, or you can do it on Linux. And what you get from that is actual proactive alerts and a shorter mean time to repair for application performance problems. So what have our customers found? Or what are some case studies? Here's a case study of a DB2 backup job. This DB2 backup job starts running and locks some tables. And this is just the fact. This is what it did. Of course, you didn't know this while you were trying to analyze the problem. And then essentially your response times start going up, and it goes over the SLA. Memory becomes full, and you get an SOS, and it stops passing the task. So things just start going really badly. And so you would look at this, and once you get here, what you're seeing are symptoms. You're not seeing root cause. And then one of the analyses you could do is that you really need to do something about the KICS DSA. That would be a mistake. What ConicIT will do is, because it will pick up this anomaly about the DB2 backup job that's running over its time and locking the tables when it shouldn't be, you will see the alert around that, and you can go back and see what was the issues that happened then. And then, of course, you can fix the right problem, and it becomes much easier to diagnose. You need to do something with this DB2 job, not necessarily about KICS. Another case study is an SLA breach. So a transaction response time went too high, and this is actually the example I showed a little bit earlier, and the QRTCB percentage is too high. So what's the wrong analysis? You're saying, I've got a problem in KICS. I better restart it. Now, that, first of all, is not the problem, and it probably won't solve the issue. But what you'll see from ConicIT, as I showed earlier, is that it will actually, because we've captured the anomaly and we've given it a specific job or task that's gone over its time and it's behaving abnormally, we'll be able to point you to that job and say, this is what's actually started the anomalous behavior, and you probably want to, and of course, you'll probably want to do something about that, because that will solve your problem as opposed to just restarting kicks, which won't solve your problem. And finally, a case study about MIPS on demand, where essentially there was something going on, and every workday of the month, 30% more transactions happen in a general way. And there are several batch jobs also going on, which cause the CPU usage to go up to 80%, which should be usually 60%. So if you're working as normally and you were at 60%, then this extra 30% wouldn't matter. You wouldn't be going over. You still have enough reserve capacity to handle it. But if you're at 80%, as what happened now, you would actually think that what you have to do is open an engine to start handling this additional workload. Now, that, of course, would solve the problem. It would just be a very expensive way to solve the problem. But if I actually knew this information about the fact that the CPU usage went up to 80%, I could say, I see I'm going up to 80%, and it's because of these batch jobs. Now, based on that, I still may decide to open the engines. That may be the right thing to do and spend the extra money. Or the right thing maybe do is to throttle back the specific batch jobs. But again, we can't do that. We can't perform the action, and we don't want to perform the action for you. What we want to be able to do is point you in the direction, show you the issues, show you the facts, and allow you to make the right decisions relative to your system. So in summary, why ConicIT? ConicIT really leverages your existing monitor. It's completely non-intrusive. It leverages your monitor by gathering information as if it was another user. It gathers that information, and what it does is build up a behavioral profile. So just like a smart operator, it learns your applications and your transactions. And it learns to differentiate between what's normal and what's abnormal for your specific application. It captures and aggregates that information and stores it for you, so when there is an issue, you can go back and look at it. And what it allows you to achieve is first fault problem resolution. So rather than having to wait for a problem to recreate itself, which tends to be the norm in trying to find a problem, you find the problem faster and you can fix it the first time because you've captured the information around the problem that lets you identify it quickly. We provide robust alerts for problem identification. We provide the information that you need for root cause analysis. And we have lots of graphing and analysis tools that help you understand what's going on at any given time with your application. Customers are seeing the benefits of finding anomalies before they affect users, knowing about service degradation before it affects users, the lower cost of being able to understand as quickly as possible when issues happen, and being able to point the appropriate subsystems that cause those issues. And you can also use it to save MIPS, because understanding what the behavioral profile of your system is means that you understand how your system should be behaving at any given time. And if it's not behaving appropriately, if it's using too much CPU or there's some issue like that, you can understand, is this something that's normal, is it an anomaly, and how you can react to that, saving you MIPS if you're using subcapacity pricing.
Okay, thank you, Jacob.
Back to Deb now.
Thanks so much. So what we've done today then is we've discussed the ConicIT solution in greater detail. If you'd like to have a deeper dive into the product, we can schedule a one-on-one consultation. We also can provide to you, as we've mentioned to a lot of our customers, a free evaluation software. So if you need to do a free proof of concept, that is available as well. We'll provide you details on how to contact us in just a moment. But what I want to do now is see if we've got some questions. Remember just to type in your questions in the chat box. Okay. Here's one. Can you use ConicIT with multiple sysplexes?
Yeah,
Jacob?
certainly. I mean, yes, can you hear me?
Yes.
Okay, sorry, I was on mute. Yeah, certainly. You can use it in multiple syntheses across LPARs. Yes, no problem at all. We just connect it into the appropriate monitors, and we can get all that information.
This one has to do, it looks like, with Z-Aware. Can you prime ConicIT with Opera log data?
No.
Z-Aware.
I know Z-Aware allows that to happen, where you can actually get the logs and use that to build up the behavioral profile and the learning beforehand. We can't do that. In a standard proof of concept with Conic, we install our system, we hook it up to your system, and we let it learn anywhere between 3 to 6 weeks. The system lets us know how it's unattended, so you don't need to do anything to those 3 to 6 weeks, but we need to get the data to build up a behavioral profile. There's a way for us to actually get this information from your using logs.
I think you just answered the next question. How long does ConicIT take to learn my system?
Oh, okay. It's around 3 to 6 weeks. It depends on how much data we're collecting and when the system senses that it has enough information. So what will happen during that time, you'll actually be able to see some graphs and interesting things about what's going on with your system, but we won't issue alerts because we're very careful about the kinds of alerts we issue and making sure that we don't issue incorrect alerts. And we'll start issuing alerts 3 to 6 weeks after the system's been installed, when the confidence level of the system is high enough.
Okay, thank you. Does ConicIT work with application performance tools like Strobe?
Yeah, any tool that has an interface that we can get into and gather the data from with Strobe is very easy. We can do that through 270's grading too. We can gather the information use that to build up the behavioral profile for those specific parameters, and then use that to issue alerts and root cause data.
The next question has to do with resources. It looks like what resources are needed for Z-Linux?
Oh, okay. Z-Linux or any Linux, it's really simple. It's a standard machine, a 2-way or 4-way CPU, a standard Linux on top of that, Red Hat or SUSE Linux, and essentially some storage, again, 8 megabytes, and a disk. It's sort of equivalent to what would today be a normal desktop machine at home. And that's all that it needs in order to be able to handle this.
It looks like we have one more question. Does ConicIT work in the distributed environment? I guess I'm taking that to mean the non-mainframe environment.
Okay. Not on its own. We actually have a partnership with a company called CoralSense, which does work in the distributed environment. So we need a monitor that we can hook into to get the information that we need from the distributed systems. CoralSense is an example of a system that actually can do that. Once we're hooked in there, then we can start working together with them, covering both distributed and mainframe. But ConicIT on its own is specifically tuned towards mainframe environments.
Okay. We just got another question. How does the product handle holiday periods where usage varies from normal?
Yeah. We have this notion of something called a special date. A special date can happen in 2 ways. The system can learn about special dates if it happened during its learning period or while it's running. And you can also preset special dates. You can tell them there are certain days of the year that it will be behaving differently, and it needs to handle them differently as part of its behavioral profile when it builds up this behavioral profile. So it's a great question. It's clear that there are things of the year and that need to be handled differently, and the system does it very well.
Well, the questions keep coming in. So the way we're going to work this, folks, is that we'll continue to answer your questions until they're all gone, or we're at 50 minutes to the hour. Okay. So the next one is, how long is the retention period for the mainframe data on the Linux server?
You can configure that. So we have we collect the data on the Linux server. We tend to collect up to a certain point. I can't remember exactly the default. I think it's 3 weeks or a month. But you can, of course, then dump that data whenever you want and store as much of it as you like. And you can actually configure us to handle more. But if you do that, of course, you have to make sure that the machine that we're running on is big enough to store all that data. So one of two ways, use our standard, or I would say dump it and save it, or increase the size that we can run on, but then you have to have a much larger server that we can run on.
Okay. I don't see any more questions. Going once, going twice. Okay, I don't see any more coming in. So, hold on a minute. Check the chat box one more time. Okay. So if you do have questions after today, please send them to performancequestions@stsusa.com. And I want to thank you for joining us today. I want to thank Jacob as well. If you want to contact us, you can contact us at our website below. And then also I wanted to let everyone know, I don't think I mentioned this in the beginning, that we did record this webinar. So we will place that out on our website in the next few days so that you or folks on your team can download that at your convenience. So again, one last check of the chat box here. I don't see any more questions. Well, thank you again, everyone, and have a good rest of your day. And thanks a lot, Jacob.
Thank you. Good night. Bye-bye.
Bye-bye.